Good morning. How are you doing? Hello, hello, hello. Thank you so much for joining me with another math lesson with Mr. Woodford. Today, what I would like to do is dive into our brand new unit, which is Unit 3. We'll be covering something called rational numbers. A rational number, just to start off and explain to you what a rational number is, a rational number is a number that could be, for example, it could be a whole number, such as 2, right? It could be one of the counting numbers as 1, 2, 3, 4, 5, 7, 8, 9, 10. It can include 0. It can include our integers, right, that we've talked about, negative numbers. But what we are adding now, a new part of it, is something called fractions and decimals, okay? So fractions and decimals can be considered rational as well. Now, that doesn't mean all fractions and decimals are rational, but it includes a good amount of them. I'm going to go through, we're going to dive into this new unit. We're going to talk about what makes something rational, what makes something called irrational. And hopefully as we dive in, we'll be able to grow in our understanding of what a rational number is. But the very first thing we're going to start off with is lesson 1 of unit 3, which talks about multiplying fractions. So if you have your packet along with me, feel free to look on with me as I share my screen. Awesome, right? Just make it a little bigger. Okay, as usual in any of my videos, take a moment right now, pause the video if you need to be able to look at the Bellwork, right? Look at the Bellwork and see if you can begin to solve that right there. It says, what is your greatest concern when you think about playing around with fractions, when you're working with fractions? And what is harder for you to do? Multiply, divide, add, or subtract fractions. So take this moment, pause the video, and answer the Bellwork question. All right, so I'm hoping that you took a time to answer it. Now, I can't go over this one because everyone's answers is different, and I apologize in advance. I'm looking for something that just needs to grab out of my bag. So now you're like, Mr. Woodford, you're all over the place right now in this video. I apologize in advance. I apologize in advance. All right. Be able to write on the screen as we talk through this lesson. Whether your experience with fractions are positive or negative, fractions are an essential part of math. They're an essential part of the number system. They're an essential part of the number line. And becoming comfortable with them is a big deal, because as we move on, we'll have to be able to play around with them, adding, subtracting, multiplying, dividing, right? Identifying which one's greater than what fraction-wise, and they become integral, right? Even in everyday life, they're integral. I mean, I love whole numbers and I love integers that we've gone over, these negative and positive numbers. But I know for me, when I'm cooking in the kitchen, I can't always use whole numbers to make certain things, right? And I'm not a baker, but I know my wife is baking a cake. There's no way she can keep putting a full cup of flour, a full cup of sugar, a full cup of eggs, a full cup of milk. Those things would not produce a good cake. No matter how it seems like, oh, they're all the same, it wouldn't work. You need percentages and you need fractions. You're going to learn as we go into it, fractions, percentages, and decimals, they all live in the same playing field. They all live together and they all are almost all the same. So to start off with, please, let's look at activity 1, right? I want to take a second to say, okay, let's, in addition to the Bellwork, if you're in class, I'll have you add this into your Bellwork. But for now, I want to take a second and look at the activity 1, see if you can figure out where these 7 additional fractions live on this number line. They all fit in the box. See if you can figure out where they belong. Right, and that's another time for you to pause the video. It may not say it on the screen, but please do so as well. Great, and let's dive in. Let's dive in. Let's see. Hopefully this works. Okay. No problem. what we want to do is we want to say, okay, let's find out what everything is. Now, the first fraction here is 1/2. We should know that 1/2 really means in the middle, right? It's a half. It's you take 1 and you chop it in half. So 1/2 should exist in between. It's right in the middle of all these numbers. So let's put 1/2 right here. Cool. So 1/2 is done. All right. Now notice that these boxes are separated, right, in a way where there's actually 8 of them if you include 1. 1 is the equivalent of 8/8. Okay. 1/2 is the equivalent of 4/8. Okay. I just wrote it as 1/2 here, but you should recognize that 1/2 really is 4/8. Right. Just like you can write 1/2 as 6/12. You can write 1/2 as 3/6. Right. Anything that shows that the top number without a doubt is half of the bottom number of the denominator. Okay. So if this is really broken down to 8 pieces, you should be able to say, okay, well, this means this is 1/8. This is my 2/8, but 2/8 is not up there, Mr. Woodford. What's the equivalent of 2/8? You should know that is really 1/4. Okay. Then the next thing is 3/8. That's up there. 4/8 we have, or 1/2, right? So we got 3/8, we got 1/4, right? We got 1/8. Then 4/8, after 4/8 is 5/8. After 5/8 is 6/8, right? But 6/8 is not up there, Mr. Woodford. Remember, 6/8 can be reduced or simplified to 3/4. Let's call this 3/4. And finally 7/8. Now, obviously, it was actually set up to a place where you can just write them exactly as it is. But my goal is to make sure you recognize fractions are on this number line. They exist, they're real numbers. In addition, some fractions may not be written in the form where the bottom number is 8. They may not have the same denominator because maybe they've been simplified. But you and I know how to simplify them. And if you don't, throughout the process of today's lesson, when we multiply, I will show you how to be able to simplify. And sometimes simplifying is very easy. Like, for example, with number, like with 4/8, you could divide them both by 2 and you get 2/4. You divide it again by 2, you get 1/2. 6/8, you divide them both by 2, 3, 4. Right? Sometimes if they're both even numbers, then it makes it very easy to be able to divide them and simplify them. Just divide them both by 2, top and bottom. But you can also say, okay, what do they have in common? So for example, like for 2/8, they both, I know 8 goes into 2. Let me divide them both by 2 here. Or for the middle one here, they both have 4. 8 goes into 4. Let's divide them both by 4. Okay, so those are some easy techniques. But let's go into what we're doing today. Specifically, we're going to start off by multiplying fractions. So I picked multiplying fractions out of the 4 operations because I believe that it's the easiest technique for you to learn or remember, as division demands you to do keep, change, flip. Addition and subtraction demands that you have a common denominator. So let's dive in. Looking at modeling problems, right? We have 2 modeling problems here. I go through 2 different types of techniques that you could use to be able to solve the multiplication problems. One technique is multiply the numerators, multiply the denominators, and then reduce the fraction, such as this. 2 times 3. Okay, and you multiply that, we know that's equal to 6. And then you do the bottom, we do 5 times 4. We know when we multiply that, we get 20, right? So when we just multiply numerators, we get 6. Multiply the denominators, we get 20. Okay, so this is step 1 and step 2 combined. Step 1, multiply numerators, 6. Step 2, multiply the denominators, that's 20. The last step says to reduce the fraction. Now, 6 and 20, are they both even numbers? Yes, they are. As I mentioned a little while ago, one of the easiest techniques for you to reduce or simplify a fraction is to identify if it's even. If it's even, then you can easily say, let me just divide them both by 2. Okay, we divide them both by 2. Now, when we divide both of these by 2, we end up with 3/10. and that would be our answer. That is our answer right here. Okay, 3/10 is our answer when it's reduced and it's simplified. Okay, this is one way of doing it, and it's multiply numerators, multiply denominators, and then you reduce the fraction. The last step is to reduce the fraction. The second technique I want to teach you is a way of not having to reduce a fraction, because sometimes if the numbers were really big, reducing a fraction becomes complicated, or it becomes a thought promoter, like trying to figure it out. Now, the good news is as we dive further into this unit, there is a way of reducing the fractions just using your calculator, right? When you type it on your calculator, type in the fraction. If you typed in 6 ABC 20, enter, right? 6 ABC 20, enter. It won't give you 6/20. It's going to give you 3/10. So that's another way to be able to do it on the calculator. But I do want you to get to the habit of understanding how to do it without a calculator, okay? Let's look at the second technique. Now, the second technique, the steps are this. We're going to cross cancellation. We're going to multiply numerators and then multiply denominators. Now, don't confuse cross cancellation with cross multiplication. Notice it doesn't say cross multiplication. It says cross cancellation. This is a way of saying if we look on the diagonals, can we cancel out before we multiply? And how do I know? How do I know I can cancel out, Ms. Orford? The way that you can identify if you can cancel out beforehand is you look to see on your diagonal if the numbers go into each other. So does 2 go into 4? Right? Is 4 a multiple of 2, or vice versa? Right? Is 3 a multiple of 5? Right? Can these be divided easily within each other? Now, 3 and 5 doesn't work because it's not multiplying. I'm not saying give me 15. That's not what I'm saying. I'm saying, can I do 5 divided by 3? And it will give me a whole number. The answer is no, it won't. Right? But however, can I do 4 divided by 2? The answer is yes, that would give me 2. So I could cancel out the 2 and I can cancel out the 4 by dividing them both by 2. What's 2 divided by 2? 1. What's 4 divided by 2? 2. Right? Now that's called cross cancellation, right? To give me a brand new set of fractions that look like this: 1/5 multiplied by 3/2. I know some of you guys are like, well, Ms. Orford, now that's an improper fraction. Yes, I know. And it's okay because we're not done solving it. And even if it was improper at this point, it's okay. I like improper fractions. I like fractions over decimals sometimes. So you'll get to a place where even if it's improper, even if it's a mixed number, I'll take that over the decimal sometimes. Okay. Now we have cross cancellation done. Now we're going to multiply numerators. 3 times 1, or 1 times 3. My apologies. All over 5 times 2. We know anything multiplied by 1 is 3, and we know 5 times 2 is 10, right? And notice here, right? This is the same exact problem as the other one over there, and it gives me the same exact answer. Just different ways of doing it. If you want to multiply numerators first, then multiply denominators, and then reduce it, go with this first step. Go with the first technique. If you want to try to cross cancel, because it might make the numbers multiplying a little bit easier to deal with when you don't have to reduce, then do that too. Okay, but that's it. This is our lesson 3.1. What I would like you to do is begin to work on the independent practice, right? We're multiplying all across here, right? Notice that there are going to be introduction of some negative integers in here and negative fractions, right? And it's okay. Begin to work with them. It's okay. Remember, if one set is negative, then your answer should come out to be negative somewhere, okay? If there was 2 negatives, which I do not see anywhere, but if there was 2 negatives, your answer will end up becoming positive, okay? So begin to get to work on the independent practice. If there are any questions, as usual, please pull your answers and put them inside the Google Classroom page. And I look forward to talking with you guys more later. Thank you so much for joining me with another math lesson with Ms. Orford. Have a wonderful day.